Hey, welcome back to another episode of the Shop Class Podcast. Tonight, we're doing Bob Ross painting electrical diagrams. Yeah, instead of mountains. And we got Keanu is a college kid. He's like a robotics engineer dude. And on the podcast with us tonight, our special guest is Matt Foley. Matt, how you doing?
Yep.
He's coming to us live from his boat in New Jersey.
Yeah, it's a solar-powered electric boat being broadcast from. So this podcast is solar-powered.
Nice. So we got jealous. We want our own system. So Matt's going to help us set one up, and we're going to install in Taylorville, Illinois with Matt Bluequist. Matt, how you doing?
Good. Getting excited and anxious.
Dude, it's a big thing. Have you received a lot of deliveries of parts and equipment?
Yeah. We got solar panels here. We got all the stuff came from Matt. I think there's one more box showing up from Matt at least that he just ordered. I have all the connectors and wires and crimpers and all that fun stuff. It is en route as well. Should be here starting tomorrow through the weekend. So everything should roll in here. Right now, I'm actually pulling up and looking up, just making sure I get everything we need for mounting the solar panels actually on the rooftops. But yeah, to the best of my knowledge, everything is coming.
Okay. Super cool. So we got solar panels coming from Sun Solar Landscape from Todd Menadier. That was super cool. And we got all the parts arriving from Matt Foley, Sunlight Conversions. Greg, where are you located again? I forgot.
Northern Iowa.
Nice. And we got Duke Lazowski from East Stroudsburg, Pennsylvania. You going to be driving?
This week, yeah. Driving in. Tim and Nick.
Oh, my God. 3 East Coast shop teachers rolling in.
And then Greg's driving down from Iowa.
Yep.
Oh, dude, that's so cool. Who else is coming? Do we have surprise guests or any other people?
I think we're going to have some surprise guests.
All right.
That'd be in the Mark Willie department. So I don't know if Mark Willie's our surprise guest or if there's friends coming. With Mark, you never know until it shows up.
Similar. Yeah. We're recognizing stuff. Oh, my God. We need to charge. Okay. Yeah. The C2C. It's over there. He's going to get the cord for the computer. Anyway, so what we do have here is a whiteboard, and we have a Keanu, the kid, and we also have a secret weapon. We have a Matt Foley, and he's our secret weapon, and he's going to somehow figure out what parts we need off this diagram, and then he's going to tell us how to route them. So let's go to step 1. Step 1 is, what parts do we need? We have an inverter 1 and inverter 2. Is that confirmed so far?
Yep, so far so good.
And the reason we need 2 inverters is because of 220. Is that right?
Yep. So unfortunately, Victron makes a lot of products. A lot of them are not sold in the US. So they're 240, but they're 50 hertz. So we just use them here. So the only way to get 240 here is with 2 inverters. I mean, it's a little more wiring, a little bit more complicated, but there's some benefits to it. So this will give us 120 and 220, and then a little bit of redundancy, yada yada. So yeah,
okay.
So the output of them gets combined. So they're 3 kilowatt continuous basically, and then they can peak to 5 kilowatts. So it's like a 10 kilowatt peak, 6 kilowatt continuous system.
Sounds awesome. And we did the calculations based on, so if anybody's curious, we did the calculations based on, I guess, peak demand from the energy bill that Matt Bluequist supplied us. Is that right?
Kind of. I mean, there weren't really many choices we had with different inverters. So we're kind of stuck with these anyway. But it's a nice size. I think the biggest load is going to be the heat pump, but that's not going to be anywhere near maxing it out. You could probably make coffee and run the heat pump at the same time.
Coffee is definitely priority.
And there's, if you wanted to charge a car from it, you could charge it at 6 kilowatt, which is not bad.
That's pretty good. That's not bad. Dude, the F1 Lightning. I feel like that's in the cards for Bloomy.
That'd be pretty sweet.
Yeah, and then you can run the job site from it. Okay, so we got Nick. Nick's gonna be there for to make sure we don't like burn down the place. You see any fire violations so far, Nick?
Are there any electricians in the group?
Not
No.
officially.
No, not officially. Yeah. We are relying on this firing diagram to keep us safe.
To the DC side, you can't really get hurt with 48 volts. You're not going to get shocked. You might get tingled. You might jump a little bit, but you can't really get hurt. But there's definitely, could be a fire risk if you do things wrong.
Yeah.
The 8 side is definitely more dangerous. It's you sometimes you get fooled. You're like, oh, it's like these little blue boxes. Like, how much power could there possibly be from these batteries? But no, it's the same exact thing that comes out of your wall. Same exact.
Yeah, the wall's serious. AC will kill you. DC, I took 400 volts on purpose just a couple weeks ago, and I've taken 100 no problem. So that's on DC, but on AC, I wouldn't be talking to you today if I got the AC. So Edison was right. But
where on DC? What? Between what and what?
400 volts on the Tesla pack. It was open.
Wait, you did this on purpose?
Yeah.
Between like your left hand and your right hand?
Yep.
And you must have hurt really bad, right?
No, it just if you feel it up to your elbow, like you go, whoa. Yeah, no, it doesn't do much more than that. No sweat. I mean, it feels like you drank a shot of coffee or something.
I've got
You're like, oh,
400 just on one finger between two little studs, and it burned my skin instantly. It was incredible.
Oh, that's different. You might have had some resistance. You had an arc. That's why. You were probably connecting something. That's what happened. You got an arc, am I right?
No, it was on a circuit board. It was the back of a circuit board at 2 pins, and the capacitors were 400 volts.
It sounds like you were close enough to make an arc through your skin. That's what, if I were to guess.
Yeah, maybe.
Okay, well, moving into come on in. Yeah.
Oh no, I'm working.
Oh, okay. And he's helping me with. We're doing this off grid system. Well, not this exact one, but we're trying to figure it out. And we got the guy in Jersey does it on his boat, and we're going to do it in Illinois for a teacher for like a job shop office, like a trailer that goes to the job site before they build a house. That's really cool. Yeah. Victron system.
Nice.
So
Cool.
cool. All right.
I'll see you tomorrow.
Awesome. Yeah, sounds good, dude. Thank you. Yeah, man. I know. Every day is wild.
Yeah. Okay.
Okay, cool. All right. So that was Michael Bream, EV West. He was just stopping in. So he kind of like helps out with the project, man. Wherever we get stuck, dude, he knocks us, he gets us right out of the sticky point. It's amazing. It's like having a tow truck with you all the time. Okay, so Matt Foley's our tow truck right now. So what should we put down? Oh, let's get this closer. What should we put down first? So we got our inverter. Why'd you reverse those? It's just the way it is. Okay, we got 2 over here and 1 over here, and then there's what's this?
That's the
Different diagram. Should we start with that other trailer first? How do you want us to do this?
Yeah, I guess start with the photo of the actual trail.
Okay, so let's start with the photo, and we got to We got this thing here. It is okay. Yeah. Okay. Scroll down. All right. Oh. Okay. What's that thing in the middle?
That is the links distributor. It's called. It's basically like a bus bar.
Oh, but it has smarts in it or no?
It could, but there's really no need to use it. It's really just a bus bar.
Okay. Just, don't take this as an insult. If anybody doesn't know what a bus bar is, it's literally just a flat wire made out of copper. It allows it to, you put one hook up and you can tap in multiple pieces, right? That's what a bus bar is. But this one's covered, so you can't see it. Okay.
So if you scroll down just a tiny bit, you'll see two bus bars that are not covered.
Oh, okay.
Scroll down.
Do that. You hold the middle mouse.
Oh, yeah. Oh, yeah. So that's
I
a
wish I
bus
had
bar.
a picture with the cover off of that, off the links piece. I know I have one somewhere. I just couldn't find it.
That's okay. So basically, it's like one wire comes in and two are coming out, and you could add. There's three more spaces. There's two more spaces, and you didn't use them. That's all, right?
Yep. So should we walk through this?
Yes.
So we'll start with batteries.
Yeah. Wherever you feel like starting, we could put the batteries in.
Yep. So we'll do the DC side first.
All right, let's do DC right down
And
here.
We'll start with the flow. So it starts with the batteries.
And are they all 12-volt batteries, or it depends, right? Depends.
So these are 48 volts. And
Okay.
you guys haven't decided on your batteries yet, but let's assume they're going to be 48-volt batteries.
All right.
And let's assume they're going to be in, two of them like that. So let's say you have 10 kilowatt hours. You're going to have two 5 kilowatt hour packs in parallel.
Okay, great. So just so you guys know, the way you decide how many batteries all depends on how many parallels and series you have. And I can explain that, no problem. But for these purposes, let's just call it 48 volts. There are two of them, so it doesn't go higher. We're going in parallel, so it's getting wider. More amp hours. We're not going higher. That would be series. But right now we're just making it wider. It's almost like it's like the difference between Duke and I. Duke's like, he's a little wider. I'm taller, so I'm series, and Duke is parallel. All right. He's like two Mr. G's side by side in one person. But it's all muscle. All right, perfect. Okay, looking.
All right. So we need to combine these two batteries.
I'm gonna bring this in closer. All right, you guys can see it.
So they get joined at the bus bar.
Okay, that's what he has.
So I guess before that, on the positive host of the battery, there's actually a fuse in there.
Oh, all right.
So it all really depends on the kind of battery.
Fuse. Yeah.
If you use that type of fuse.
Is it on the terminal?
On the terminal itself, yep.
All right, so just put, a wavy line. Okay. So it'll just be like this. Oh, you can do that. Keanu's catching up quick. Nice. Beautiful.
All right. So you got the positive bus and the negative bus. And one thing.
Oh, we got to do. No, we don't have the negative bus yet. So that's this one. It's the same idea, except yeah. Okay, you can do that, right? All right. He's gonna fill it in. So we're right now we're combining the two batteries safely by just using a bus bar. So it just makes it super easy. What's nice is you could always check voltage there. You could tap in. You could do stuff with your voltmeter. I like that. And like I talked with Matt Bloomquist about this, we're going to do a lot of labeling, a lot of areas to check, make it like super obvious what this thing does. And that's what teachers do. We dissect the problem and we show how it works, Okay, cool. It's looking good. Any fuse on the negative?
Nope, just the positive.
Okay. All right, what's next?
All right. So what you have to be considerate of here is the lengths of wire for each battery have to be exactly the same.
Ooh, that's interesting because of resistance.
Right. Yep. So the positive and negative could be different, but like the sum of both of them have to be the same. So if you have, a 1 foot black and a 6-inch red, that's fine, but they have to be, the same on each battery. 1 foot on.
Before the bus bar.
Yep. So from the battery to the bus bar, those
Okay,
lengths.
put in a little note saying equal length. Just, you know what? It's almost like SolidWorks. Just put.
Just gonna do this as a unit.
Okay.
Then let's say like one.
You know what they do in SolidWorks?
Yeah.
Is they just go like this.
Oh, really? Okay.
Yeah.
Let's do that.
That's like who does SolidWorks here, right? Or any CAD program. Okay, you handle it. You handle it. All right, equal length, because otherwise it's going to pull from one than the other, right?
Correct. Yep. So then you even have to be careful of where you hook it up on the bus bar. So if they say this is the right way to do it, they say use bus bar because the bus bar is such low resistance that it doesn't matter. But it really actually does. If you had 3 hooked up in line and you put your clamp meter on it, you would see your amperage go up like the further you went down the line. So every one of those,
Wow.
will make a difference. So at the end of the day, will it eventually all even out? Probably. And if you're not pushing the system super hard or charging it to 100% or draining it to 0, it's probably not going to be the big deal. But, it's just good practice to do your best.
Yeah.
So like if you see on the negative,
I like your negative. It's actually tapped in the middle, not in the drawing, but on the photo. It's tapped in the middle. Should we do that for positive as well?
Yep. So that's how they should both be. I can't see it on the red.
On the red, you got it tapped on the left side of the two of them. But I get it. You don't want it like that. You meant it just.
I wonder why I did that, because
Probably just that's accessibility, maybe.
I don't remember. I definitely would have tried to put it in the middle if I could have.
Well, we're gonna hold you to it here, so nah,
There
it's all good.
was a reason. There was a reason. Anyway, do as they say, not as they do.
Yeah. Okay, so what's next over here?
So I guess let's
Shunt and a shut off.
Yep. So let's stay on the negative. So now the batteries are combined on the negative.
This is very similar to a car setup, by the way. I love this.
Yep. So
Right?
that's
Doesn't it make sense now that we go through it? Keanu's even like, dude, I totally get it.
The neurons have made a connection.
Yeah. He's a robotics kid. This is like, and he's young. He's like a millennial kid. So he makes silly jokes like this, We're trying to get him on the Andrew Dice Clay. I'm gonna help him out. We'll get him old school soon. But for now. Okay, yeah. So let's get that hooked up, right, Matt? Is that what you want?
Yep. So now we're at the shunt. So you have to
wait. I have to tell people what a shunt is. Okay, in case you don't know, a shunt is. It sounds ridiculous. Like, what is that, right? But all it is a very low amount of measured resistance. You can use that, and if you notice here, I don't know if you see my hand on the mouse. But there's a difference between this side and this side. Although this passes through like 99.9% of the energy, just a small amount, a measured amount, that's enough to take that and use it on a computer to figure out how many amps you're using. Simple way of put it, imagine going through a toll booth, but instead of them collecting like dollars, they're collecting pennies. And if you go the other way, they give you back the penny. It's just a way of counting. It's like when Duke stands at the door and counts how many people go in to the party, and then he to count how many people go back out.
So it actually measures the voltage drop across the shunt.
Right.
And it takes so it knows it knows the voltage, it knows the resistance, so that's how it calculates the amps.
Yeah. It's usually like the one on the car is 50 millivolts at 600 amps. So it's like a measured amount.
So now you have to make sure. So the shunt has 2 sides to it. It has a battery side and then it has basically an everything else side. So actually, you'll say on it, right? It says 2 battery, and what does the other side say? It says like charge and discharge or something.
It's 2 battery something, 2 system something.
The system.
Yeah,
Two
yep.
system.
Yep. So now, if you were to take someone a year from now, after it's hooked up, comes in and it's like, oh, let me just hook up to these 2 bus bars, then it will not be measured through the shunt.
Oh, right. Okay. So this is your toll booth. If someone goes around the gate and sneaks into the concert, Duke won't know and he won't be able to count it. So he won't,
Correct.
Okay. All right. So we have so that's going into the bigger bus bar that's been covered. Well, let's do the positive side now, right?
Yep. So that's
we got
just
a big shut off.
Yep.
This
Just
is like the exit, the back door to the pub. This is a big I don't know. This basically shuts it down.
Yeah, just a big switch. So you'll notice that I hooked the switch up directly to the Lynx device. There's basically a stud that comes out, and I just tapped right into it. Same thing, go down for the shunt.
Yeah, we see it.
So I didn't want to put an extra wire in there because it's more wire, it's more connectors. So you guys can try to replicate what I did. Otherwise, it would just be a piece of wire connecting them.
All right, so if we can do less wires, that's pretty cool. But it might not work out like that.
Right.
Although, because you did nice packaging. I mean, geez, you stuffed it in the tongue of the nose of a trailer. Like that's a lot of.
Yeah.
You must. Yeah, this guy Matt does a lot of yoga or something like that. I don't know. This is like cramped. Should we go back and look at the? Let's look at the other window for just a sec. Let's look at the actual diagram. Just to compare it. Is it this one? Oh, geez, where is it? Oh, here we go. All right. So now, if we were to compare it to this situation, you okay? Yeah. Okay. Oh, I see. So here's your batteries on. How do I move this thing? Oh. Okay, so here's this going into here. So they don't do the bus bar thing. They bus it somehow with a fuse inside this box, which I guess you don't need. You did it outside that.
So the way that they're using, there's a lot of different ways to use that Lynx piece.
Yeah.
It looks like they are using it to combine the batteries, right? That's what you said?
Yeah.
Yep. So that's different. Just different. So ignore that part of it.
All right. So that's how they did it. Okay. And then I just want to compare it out. And then that's being hooked up. This is interesting. For some reason, I can't zoom in any further, but
You hold control and then scroll. You'll zoom in.
oh, really? Control? Oh my God. This kid knows all the computer stuff. So, so where do we go from here, Matt? This looks a little different.
Yeah. So the DC side, probably maybe don't use that at all, but the AC side should be
All right.
pretty close to what you guys are going to do.
Okay. All right. So should we go back to where do you want us to go next?
Yeah, I guess let's go back to the photo. So we're still on the DC stuff.
All right. Oops. Okay, hang on. Let's leave that up there. And then oh yeah, thanks. Oh no, I have to change it over here. Sorry about that. Yes. No. This one. No, window. This one. Got it. All right. It's pulling up. Do you see anything, guys? Oh, there we go. All right, so now we're going into the links power in, and now what?
All right, so that's going to be like our combiner for everything, really. So that's going to that's our 48-volt bus, and that's going to be the outputs to the inverters. The charge,
Well-
the solar charge controllers go there.
Well, let's do each wire. Let's do each one. What's this one? What are these? Oh, these are two.
So you got your positive and negative going to each inverter.
Oh, okay. So let's do that. So give me. Okay, you got that?
Might get messy, but
No, that's okay. Go on top if you have to.
so we do 2 from here, 2 from here, then 2 from here, 2 from here. to here. Look, it's both charge controllers.
Oh, you're right.
Those guys.
Yes.
These guys,
Yeah.
two of these guys.
Yeah. So just make it less messy. Just put it up top.
I'll go around.
Just put it up top. Yeah, just go on top. Yeah. But just do this one first. Just do this guy, the main guy.
Oh, okay, you want
Yeah, do main
Oh.
main things first. Yeah, simple dimple. Yeah, there you go. All right. You want to talk to him? They want to talk to you, Keanu.
hang on, give me a second.
Okay.
A busy guy, you know.
I know,
gotta make
I
time
know.
for everybody. Yeah.
All right. Don't worry. You go out there. It's okay. I can talk. I can do this thing. So, okay. So you're connected. Oh, we did it. Okay. That's connected now. Matt, what's the next wire we should connect?
So positive and negative to the other inverter.
He's got it.
Oh, both of them. Okay.
Yeah. Is it, can you see that?
Positive, negative.
Oh, you know what? Turn that one off. That's glaring now too. Yeah. I don't know how that happened. There we go. Okay. It's on there
Okay,
now.
Ron, let's see.
Oh, okay, good. All right. So now, what do I do next there, Foley?
So now we've got the positive and negative from the solar charge controller.
What is this? That's this?
Yep. So right now you guys just have one. Ultimately, if you build a trailer or whatever, you have two. But right now it's just one.
Okay, so I need positive coming out of here. Charge controller. So I'm gonna move this guy. I'm gonna put him in the center. Is that cool?
Mm-hmm.
All right, center of the action. CC, charge controller. And then I'll do a red wire and a blue wire. How's that?
All right. Good.
Okay.
So back to the inverters real quick. Those lengths also should be the same. The positive and negative to each inverter. Yep.
Okay. That's important to know, people. Equal, equal, equal. Yeah, otherwise we're going to get too much from one and not the other. Okay.
So that's all the high current stuff. So now we got solar, we've got the inverters, which are also chargers.
Well,
Then it's just
yeah, before you go on, I would like to put, I think we should do it later, but I'd like to put the wire size and the terminal that we need. Do you want to do that now, or do you want to just do it at the end when we have it all mapped
I
out?
think at the end. So I don't
Okay.
even I know the wire sizes, but I don't even know all the terminals. Like that's the switch I ordered for you guys. I never used, and they don't state what size
Okay.
lugs they need or anything, so I couldn't do all of it.
All right, no problem. All right,
Um,
what's next?
So that's the high current stuff, and now it's just like the little accessories. So your the Serbo GX.
Wait, let me see where that is.
Right. Yep,
Ooh.
right there. Yep.
Whoa. That thing looks scary. What is that thing?
That's the brains of the whole system.
Oh my God.
So that needs power. 48 volts, positive, negative.
All right. So it needs 48 volts from the batteries?
Yeah, but it comes off the links.
Oh, okay. We're now using, I already hooked up the charge controller. We only have one. Yeah, get rid of the other one. Yeah. But this guy here, see this, Mama Jamma. This guy here, that is the brains.
Okay.
And that's going to have 48 volts going in. Did you say, oh, and it comes from this guy. So we got to get 48 volts up there. Although it looks like magic. I think he went through this hole.
Yep.
You
So
see this hole?
it comes with its own little wire with
All
lugs
right, so
on it already.
we need 48 volts DC
From here.
from here.
What is this called in the middle?
That is called the Lynx Power Pro, but it is literally a bus bar. Am I right?
Is
Yep,
it like
just a bus bar.
power distribution panel, or it's just
What's
like
PDP?
just power distribution panel?
What? I don't know.
Yeah, whatever. That's fine.
I'll just propose
Okay,
that.
he said that's cool.
I'll do bus bar pro. How's that?
Okay,
It's bigger.
great.
And then
Okay,
we'll do
get-
the brain.
Put the brain and power it up. You know, brains takes power. Definitely need power.
Okay. And then the shunt also needs power.
Really?
Yep.
Yeah, I got that here, I think. Or no, is that what that is?
I think so. The shunt is just going to take a positive, actually.
No, it's positive, negative from the two sides.
So it gets the negative from the high current connection, and then it's just a single positive wire that goes to the links.
Oh, you mean this is like a smart shunt? Like it has brains in it?
It does. Yep.
Oh, okay. The one on the car is like just piece of brass. It's like dumb. Okay. Yeah. Okay. You could go. Yeah, you could do that. But then, where's that go? You got to put it
Oh,
to the
right.
brain.
Okay, so that's right.
Yeah. Porthole. He's using portals. This kid's like a sci-fi guy. That's Matt. Matt did that. Matt, you like sci-fi? Is that why you're doing the portals?
Get the hole in the plywood.
Yeah. All right. Keanu's gonna catch up. So now I see a whole bunch of plugs going on here. We'll solve that.
So that's communication. So maybe I don't know.
One,
Don't
two,
maybe
three,
don't
four.
even messy up your drawing with it if you can't fit it. That stuff's pretty simple, So like the solar controller gets one,
There
the shunt gets one.
Wait, no, hold on. I gotta add those in. So tell me what I need.
So it's called a VE Connect. It's Victron's communication cable.
Okay. Those aren't USB?
Nope. They're their own little weird thing.
All right. So there's some plugs. So where am I going to?
So the shunt gets one.
Oh my God, really? That's so
The
cool.
portal.
Oh yeah, I could go into the portal.
Gee, I have got to head out, but I'll catch
Yeah.
up on all this. This is actually.
Oh no problem, man. Thanks a lot. You got us started.
This was actually-
No, yeah, you were worried about it?
A little bit.
It's kind of interesting, right?
Exactly.
It's the same as the car. It's the same. Keanu's into it, man. Thank you. He was digging it. He was like, oh, it's like the same as the car. I'm like, yeah. He was actually afraid to do. I was like, you got to help me. He's like, no, I can't. I'm like, dude, you got this, bro. That's why we're teachers. We encourage people to take on projects that they don't know how to do. Like us.
If you can build a robot, you can do this.
Yeah, right. He knows how to build robots. Like, hello. All right, so I'll just send out. Okay, so this one's going here, and this guy's. I'm gonna just give some communication right there. So I'm gonna say shunt. All right, and what? Give me another plug. Where am I going?
The solar controller gets one.
Solar controller. Where's my solar controller?
The MPPT. Yep, the guy in the middle up there, right?
Why did I put CC? I should have put SC.
You did CC for charge controller.
But is that the same as solar controller?
Yeah. I mean, it is, but it might get a little confusing.
Solar controller. Okay, I'm gonna go out over here, all the way up here. Take a right-hand turn, get off at exit 161 for Paramus. All right, we're good. Okay.
I think that's it for those guys.
Oh, really? Because you got a lot more on this.
Yep. So
photograph.
one of them. So the communication between the two inverters is just an RJ45 patch cable,
Where's the RJ45? I don't even know what that is.
an Ethernet cable.
Ethernet
thing-
cable.
Oh. And where they go straight to each other, or they go through the box here?
So it goes from one inverter to the next. It's like a daisy chain. One inverter to the next inverter, and then to the servo.
Oh, so
And I ordered those cables for you guys. There's no difference between them and anything you pick up anywhere else or one you make. But if you need support from Victron, the first thing they're going to ask you is if you're using their cable.
Gotcha.
But it's just a regular Ethernet cable.
okay. I went from 1 to 2 and 2 to the brain.
Yep.
Okay. What's next?
So out of the servo, I think the only other thing you guys are going to have is the HDMI cable, and that goes to the display.
Oh, no way. Oh, which is not in this photograph,
Oh, that's a bummer.
right?
It would be just above the picture.
Okay. That's okay. There's one on the there's one in that wiring diagram. I'll pull it up in a sec. All right. So I'll put a little display up here. That'll be the coolest thing. I've seen that. It looks great.
Yeah, it's a cool display.
It is cool. All right.
So Matt, is that display like a touchscreen thing where when we put this on the wall, I want to make sure it's very accessible to
Yep.
not only see, but maybe even access by touch, right? Okay.
Yep.
Okay. That's cool. How do you power that thing up? Is it just from that wire?
Yep. Just one wire. Yep.
Wow. Should I go back to the drawing or stay here?
I think that's it for the DC stuff. That picture
Okay.
all the way on the right is a 48 to 12 volt DC to DC converter, but I don't think you guys need 12 volts for anything.
Is that this?
That guy, yeah.
Oh, the only time he'd want 12 volts is if he was charging like a car battery, which it's an office trailer, like a job site trailer. So I don't think you don't have 12 volts in there, right, Bloomquist?
Only thing we charge is our batteries that we just plug in that'd be on the AC side.
Yeah, that's
Or-
AC.
well,
Yeah. You just do that the same way. Yep.
yeah. So
So
yeah.
no, we don't need it. Oh, interesting. Yeah, we don't need it. But this guy needs it because it's a car.
So that's a landscaper trailer. So we put a fan in. So that runs the fan. It's like an RV fan. It runs the fan, the lights.
And you did not include that in the
Correct.
setup anyway. So, okay.
Did not.
All right. Okay, now what's happening next?
So one more thing on the DC side is just the chassis ground. So that's the green wires.
Oh yeah.
So the inverters have a chassis ground. I don't know. I ran it to basically the chassis of the trailer.
So we're just connecting trailer frame on that then, right?
Yeah, I guess, yeah.
Well, what you could do is wait.
Or do we
let
have
me
to
ask
put
you
like a
question.
ground rod in?
Yeah, let me ask you a question, Matt Foley. Do we need to hook it to the ground on the AC ground, or is that not cool?
So let's see.
Because like chassis ground is not actually ground. That's just chassis.
Yeah, so it's not.
And then
it-
house
this
ground is really ground, like dirt.
right. So this is just for safety. So it's going to, if there's a metal case on something and it gets energized, this will blow the fuse. So where does it connect to the AC? On boats it's even more confusing, and sometimes we do it and sometimes we don't.
You have a water wire. It's like that's your ground.
Why am I so on an RV? Why am I drawing a blank here?
Don't worry, we can come back to it. For now, we'll just put chassis ground. Think about it. Well, it's similar. Wait a minute. It's similar to your. It's no different than this trailer in the photo.
Yeah, no, you're right.
So what'd you do here?
I'm trying to
Chassis
remember.
ground?
Yeah, chassis ground, but
Tomorrow,
I'm trying to think of where the AC ground comes into play.
Because what we could do, Matt, if this, like, I can have a ground pole that connects that I just lug onto the trailer frame that we put into the ground, and we can pull back out when it's time to move. And then that also connects. Is that kind of what we have to do? Is that what we're kind of like? Because I know when we do our temporary power or obviously when we hook up the house, we put a ground rod in. Is that what we're trying to do? Especially on the AC side of things?
So is there anywhere that you know of that your current AC system hooks up to the chassis?
So when we hook the trailer up to the grid, the temporary power pole, or to the house, whatever we're doing, we literally run a cable, a feed just to the main breaker, or to the meter, and then up into our panel. We have a conduit that we slide the wire right up in there. We hook into our temporary power pole, and it's just like if you're connecting to the house. So, and then the temporary power pole, what our electrician done, he'd wrap the ground wire around the pole. So when we bury it, it gets buried in the ground with. Now, of course, when we do the house, we bury an 8-foot ground rod. We drive an 8-foot ground rod into the ground, and then there's a ground connected to the meter base outside. But when we're hooked up to the trailer, it's just the temporary one that gets buried, say 3 feet in the ground with the bottom of the temporary power pole. And we can do something like that very easily. That connects, that I just bolt onto the frame if that's where we're grounding to. And then the frame would ground to the ground.
Right. So your electrical panel, even if it's not done on purpose, it's probably basically grounded to the chassis of your trailer, right?
So the panel, so the breaker box inside,
right. Yep.
I mean, it's just bolted to, just like you would in a house. It's bolted to the stud that's connected to the foundation, which in this case is the trailer, which sits on rubber tires.
Wood studs or metal studs?
We did metal studs.
So effectively, then it would be kind of.
But then the metal studs sit on a wood frame in between,
right?
The metal frame and the metal studs.
Yeah, it gets weird. So it's kind of like a floating system.
Yeah. So we're tying back to the ground, all the way back to the meter box, just like we would in a house.
Right. All right. Well, let's put it on the back burner for a minute.
Sure.
All right. Okay. What else we got?
So on the DC side, that should be everything.
All right. Wow. That was easy. Jeez. I thought you said this was complicated. No, he never said that. I thought it was complicated. Man, we can hook this up.
It is and it isn't. You'll see.
Okay. What's this little wire here?
Maybe it goes to the DC to DC converter.
Oh yeah, because there's there must be a hole back here. It doesn't go anywhere. How many greens you got? One. There's only 1, 2, 3. Why is there?
So the one to each inverter, and then to the chassis of the trailer.
Oh, and that's what you got going on over here.
Yeah.
So the inverter, okay. So the inverters are grounded. Wait. Oh, I got you. I got you. So they don't get grounded. They get sent to the bus bar. Then from the bus bar, sent out to ground.
So the ground is actually, in that case, it's the negative of the battery.
Oh, okay.
But so it's never current carrying, only if there's a fault.
Oh,
So anything with like a metal case in it, that's what you're hooking it up to.
okay.
So if there's a fault current, it'll trip your breaker or blow your fuse.
Oh, and these are these are hooked up to the negative inside of here, the 3 wires.
Yep.
Negative. All right. Okay. All right. What else? Yeah. What else we got to do here?
So that's everything on the DC. So now it's AC.
AC/DC. Back in black. I hit the sack. It's been so long.
Oh, you know what? I forget. Let's
glad
go
to
back
be
to
back.
DC. Let's go back to DC and do the solar.
Oh yeah. All right. Let's do it. Should we go back? What should we do?
So I guess they don't have. So on the upper left, that gray box, that's one of the things that I told you to order, Matt. Right, the solar combiner.
Yep, that with a couple breakers or something, I believe.
Yep.
Yep.
So you guys are going to have 2 strings of 3 panels. So you're going to have 3 solar panels in series. And that's going to be on one wire, one 10 gauge wire. And then the other 3 in series on the second 10 gauge wire. And they both go to that gray box.
Okay. I don't have a place to put it, but I'm gonna put. Can you guys see solar panels here? Down here? Yeah, you can see it. I'm gonna put a solar panel, even though it wouldn't be this small. 3 in parallel, you said?
3 in series.
2 in 2P?
Yep, 2P, 3S. 3S,
2P,
2P.
3S. Oops. And how many volts are they each?
Like 53.
Ooh, nice. So 53, 53, 53. So that's 159. And then in parallel gives it more amps. And I could go through the parallel versus series song and dance. I'll explain the whole thing. But basically, it's getting wider here. This is going in series, but these are connected in parallel.
Yep. So it's going to be a separate run of wire. So they're going to get connected in parallel back at the solar combiner box.
Oh, so you first run them in.
Yeah. So 2 wires are going to go to the roof. One is going to go to, let's say, the negative on panel 1, and then panel 1 gets connected to panel 2, and then 2 to 3, and then you grab the positive from the other side of the panel. If that makes any sense at all.
Yeah, and then how do you do parallel?
They get combined down at the box. You could combine them at the roof, but that just gets messy. So you think of it as two completely separate strings of 3 panels.
So can I do this? So how many wires come off the roof?
2. Well, sorry, 4 wires, but they're
So like this?
Hold on, let me try to make your screen bigger. And I'm working from just my phone here. Yep, that's right. Yep. So then, so now your third panel,
Yeah.
that guy now a wire comes off of there, back down. So that's going to be, let's say your negative or your positive. I can't really see your color. That comes back down to your combiner.
Okay.
Yep. And then same thing on the bottom.
4 wires. I got it now. Okay, 4 wires.
Yep. So then there's going to be 2 breakers in that box. 1 breaker for each string.
Breaker 19. Eastbound and down. Yeah. Okay. And then what happens from there?
So there's going to be 2 wires out from there to the solar controller.
Up there.
Mm-hmm.
All right, I'm gonna use a portal. They arrived.
Is your portal, is that a official symbol in the CAD world, or what is it? Sketchworks? What's it called?
This is
SolidWorks?
straight out of like just cartoons. No. This is
I kind of, it makes sense. I get it. I like it.
I think they do like that squiggly line or whatever, and they go like this, and then they show up somewhere else. I don't know. I'm not sure what to do.
Yeah, I can't envision it either.
Yeah. Okay. So now, okay, we're hooked up to the solar charger. Solar controller. That guy's going to be like, "Oh, you're 159 volts. We can handle that." What do we do with that? Is it going to change it, or does it send it?
Nope, it drops it down to what the batteries need.
Oh. Or what the inverter needs, right?
Well, technically both. So it's going to go to the bus bar, and then it just go wherever whoever's going to take it. It's either go straight to the inverters if they need it. Otherwise, they'll go to the batteries.
Oh, that's cool.
Well, what's cool about this part of it, it just happens. Like there's
It's
nothing
physics.
controlling
It's
it.
not. There's no computer. It's physics.
Yeah, whatever has less resistance, it just goes.
Got it. Okay. So what next?
So
Wait,
then
Anybody have any thought? Everybody have any thoughts on this? What do you guys? Are you guys cool? What do you guys think, Duke? What do you think of this, man?
Looks nice and neat. As long as you can follow along, I can cut even wires.
Yeah, we're gonna have you splicing wires, man.
You know, I thought this was going to be fun at night. We're going to have to go to school at night. It's going to be like night class. Night class with Mr. G. What about these food trips?
Yeah, right?
Beverages.
Oh yeah, you're on summer break. Why don't you go to the beach? Nah, we're gonna go install a solar system and
Yeah.
In the middle of some cornfields and bean fields.
Yeah, Mr. G's cracking the whip.
Dude, I'm feeling way less nervous about this now after Matt explained it all and everything. Like and also obviously Matt is able to do a nice, neat, tight panel within, let's say, 3 feet or whatever there. But we're going to have a wall that is 80 inches by 30 inches tall, spread out. So, and then I was thinking, because I was like, oh, I like how he ran the wires behind everything, but we'll want to keep all our wires out. So that way we know what wires go into what. So that makes that even easier. And it'll be, I'm way less nervous about this now than actually I was really never nervous. I was just like
I was
like
nervous,
way less I feel way less
and I've
clueless
done
now
this
about
stuff before.
But yeah, you guys should definitely, like you said, keep everything exposed, and then you just literally just follow a wire with your eyes and see where it goes.
Like I said, we got to make it as simple as possible so we can show students.
I would have put my stuff in all like conduit or like some kind of chase, but I just didn't even have room for that. So I'm not thrilled that those wires are exposed, but I didn't really have a choice. But yeah, definitely keep your stuff exposed.
Cool. All right, so that's cool. Nick, what do you think, man? Hold on, he's got to unmute it.
Yep. I don't know. As long as, for display purposes, show power coming in from the panels and, kind of a roadmap for the kids to be able to follow and understand how power is coming in, how it's getting transformed from DC to AC and then out to AC.
So one of my ideas I told Ron Nick was we'll make labels with the label maker or whatever, and then also make have like arrow labels, that show the flow of what's going what, AC going this way, DC, whatever, the power. But yeah, I thought that same thing because really that's what it's all about is directing and controlling where everything's going with this.
Mm-hmm. Now, are you gonna not just for kid use wise have them interface with DC and like have a couple USB plugs, let's say, for their devices off the DC side of it and the AC side of it, so they see the difference, or
I'm sure we could do something like that, especially since I'm guessing this is something we could add on to later on. I did want to put some kind of like charging station like right underneath of it, because underneath of it will be two normal wall outlets that are part of the trailer.
Mm-hmm.
But I thought it'd be cool to have like the charging station for like so when the kids, never charge their Chromebooks and on the first period of the day and they need to charge them up for later on when they go back to school. And of course their cell phones, which I'm like, well, you don't need your cell phone during the day, but we know that's not true. So people are always trying to find outlets to charge Chromebooks and cell phones. So I thought it'd be cool to have on the countertop with this would be sitting underneath. And then the batteries, we can actually drop wires down into the cabinet underneath and put a shelf in the cabinets and have the batteries actually stored into a cabinet so they're not out and about. But yeah, I was thinking kind of the same thing. I like the idea of, being able to add something on like that. And so, I like the idea of expanding on this or whatever. So it's gonna be cool. I'm excited. We won't turn. I'm sure we'll call Matt before and get him on the phone with the camera and make sure everything's right before we
go live.
Juice it up.
Dude, absolutely. Oh yeah. Wait, one more second, guys. But actually, I just want to introduce you to Talik here. He's a teacher and he teaches band in California. But he's also a YouTuber kind of guy, and he's been doing a lot of info about our electric vehicle build. You can follow him at Charge Positive, right?
Yeah, with a Z, POZ.
Yeah.
Mainly Instagram right now. I'm building up YouTube. I've been helping them with their social media, getting the word out about this awesome place, about how to learn all of this. More people need to know about it, so that we can have more students become the next generation of building awesome projects whichever side
they can see it. They can see this one. Yeah.
I just don't know which way on the thing it looks like, but just need more people being aware about this whole field.
That's the whole idea behind this. We're doing an install, and it's very similar to the car. In fact, Keanu was here, and he was like, "Wait a minute." Once we laid it out, he's like, "It's the same as the car. I get it now." It's just the only difference is we have no solar panels on the car, so we can actually tag you when we do this because we're going to be doing it next week. We'll tag you. You can help us with promote this program.
Sure.
Yeah, pretty cool. Can you find out what Ali wanted? I'm not sure. I think some people are leaving right now. Anyway, okay, yeah, we're stoked, man. This is super, super cool. And Matt Bloomquist, I'm so glad you're doing this. Like, this is awesome. Yeah, man. All right. So what's next? What do we do next? Are we going to do, oh wait, we didn't hear what Peter had to say. Peter's always got something. He's too quiet right now. What happened there, Peter? What do you think of this, man?
I've got things working again. Thank you very much. This is great, good looking layout, but yours is going to be just slightly different with some components in or out. Would you get Matt, one of your students, to make up a formal schematic diagram for this thing?
None of my students would know how to do that.
Well,
Yeah,
what
you
we're going to
borrow
have
somebody
to
from the
do is,
electric shop?
Now, maybe someone else's students, teachers wise, they like my students. I mean, some of them take AutoCAD and stuff, but they don't learn how to draw up schematic. And actually, I couldn't even draw it up for you, to tell you the truth. I wouldn't know all the symbols and all that stuff. I'm more of a wall cabinet, wall assembly system understanding kind of guy. And when it comes to electrical, I was telling Ron, I'm really good at hooking wire A to outlet B and all that stuff. The electrician tells us what wires, what breakers, what things we need. So I'm not a good theory guy when it comes to electrical. I am a good technician guy as far as hooking up. I have learned how to troubleshoot some things. But even like I told Ron, I can't even tell you what volts, amps, and all that stuff. Even technically, I couldn't explain that to anybody. I know they're a thing, but when it comes to wood, you don't deal with that. You talk about humidity and heat and shrinkage and expansion and contraction, and so this is what's fun for me. I'm a carpenter by trade, and I get to dive in and learn all this stuff. So this is very much exciting to me.
Yeah, you're right. The wood is not a great conductor of electricity or other energy.
Maybe unless
good
it's
insulator. Wet. Oh yeah, then don't want to get there. But no, but to get an accurate diagram of what you install and have it for reference, and yeah, just to get somebody else involved and do that, another student exercise.
okay. So, yeah, so basically it's the same as me. When I first got into this, I didn't know the difference between volts and amps. I didn't know what a continuity test was either. And I I did A to B, just follow the wiring diagram. But at some point you do know what things do. And that's where I think I can help out because I've broken enough stuff. So, but I don't know everything. But I do know that real simple, volts is pressure, or a pressure difference, potential pressure difference. And then amps is the amount, like how much actual electricity is flowing. And I actually purchased some experimental equipment for teaching, and it's on its way through Amazon to your house. And when it gets there, I'll show you. We'll just mount some stuff and we can do some tests and experiments. The same stuff I do with anyone who wants to learn this stuff. Because once you know the difference between volts and amps, you can times them. Volts times amps equals watts. What the hell is a watt? And it's just volts times amps. And so it's real simple from there. But I'm not good at house wiring. I don't know anything about it. And I'm not that great with wood. So it's a perfect, combination of people. This is great. What a cool thing. And then we got Matt, who probably knows both, but he is thousands of miles away. So we're going to get his knowledge some tonight and hopefully during the build, That would be cool. All right. So what should we do next, Matt Foley? What's the next part?
So real quick on the solar. So the 4 that were broken, it's a bummer, but I guess right now it's not the end of the world.
Oh, it's 4 that are broken?
I think it was 4, right?
Or the 4 that wouldn't be on the roof, that would be the additional. That'd be like on our extra trailer or whatever out in the yard.
So I don't know if you guys know. I don't know if they know, but the panels arrived busted, but not all of them. How many panels arrived?
We got 10 panels. 6 were perfectly fine. 4 were busted. two of which, like the middle bar, is almost like something got sat on the middle bar and pushed out. Like the center support strut of the panel itself had pushed through the glass. So, I mean, it was definitely one of these things came from like the inventory and stuff, but warehouse or something. But yeah, the 600 go up on the roof. They're ready to go, and Todd might be able to get us. Heck, who knows? We may have the other 4 by the end of the week. So
they're like, it's panels for teachers. All right, get it in the van.
So I only included one charge controller for the 6. So the other 4, I mean, I figured you guys weren't going to get to building a trailer or whatever in these few days. So it's not going to hinder anything right now.
Serendipitous or whatever that is. It's what is that when like it was meant to be? Fate or whatever. We got panels that are busted. We don't have a controller for them anyway. How does that happen? I don't even know. All right, so let's hook them up. Let's hook up the panels we still have. So we got 6 in series, 3 in series, 2 in parallel, and then what's next? What do we do next?
So that should be everything for DC, and now it's AC. So I would start a new drawing.
Oh, really? A new drawing? I'm scared. We took so much time on this one.
You could try to put all those new cables on there, but I don't know.
No. I'll just start a new one. I'm gonna take a photo.
Oh, because you only have one whiteboard? Oh, that's a bummer.
Wait, I do have another one. Yeah, I got another, but it doesn't matter. It doesn't matter. We got to go over this thing anyway. But yeah, I see it.
Let's say we need the picture when we're here anyway, so that we're not bringing a whiteboard.
Yeah, I'm not bringing the whole whiteboard. Okay, we're erasing. It's happening. Oh no! No!
Oh, I guess maybe you could have just raced the wires between everything. Oh,
Now you say something. Now he says it. All right. Okay. What's the center of the world?
put your inverters back.
Oh my God. The inverter's got to go back. Now he tells me. AC. Okay.
Yeah, I guess that's the only thing that's the same.
Okay.
All right, so here's the theory behind it.
All right.
You're going to bring in 220 volts from, the street or wherever. And you're going to send one leg of the 220 to each inverter.
Oh. All right.
Hold on.
Yeah.
I'll be right back.
Yeah.
Yeah. I'm just on a work call. Okay.
So draw in your inverter boxes, make some rectangles again.
I got him. Can you see it?
All right.
See it?
I'm back.
Yep, good.
Matt got pulled over by the boat police.
9:30 fireworks.
Matt got pulled over by the boat police.
Yeah, just a fellow sailor. They're gonna have fireworks here soon, so maybe you guys should get a fireworks show.
Oh, that's pretty cool. In Jersey, they're always doing something good. All right, so I got some rectangles. They look pretty serious. They've been Peter approved.
Yes.
So you're 220.
AC's coming in. Oh, I got some legs coming in from the street.
Yep. So one of the 220 legs goes to each inverter.
All right. We're going hot, baby. Bam! Shapow. Hot legs. Hot. Hot. No neutrals. Just hot. Okay.
I mean, they do each get a neutral.
What? I don't have a neutral.
You're going to draw in a neutral.
But I don't have a neutral. Isn't it just 3 wires?
Well, it's 4 if you count the ground.
Oh, I get a neutral? All right.
Yeah. So your middle can be your neutral. Use your middle wire.
And split it?
Yep.
Split it up?
Mm-hmm.
All right, when you split it, everybody knows you put a little dot in the split. This drawing's looking kind of funny. I didn't mean for it to look like this.
All right, so that's your in. And then, so also you have to be super careful that these wires are the exact same length.
Equal.
Because they have to be perfectly out of phase.
Oh, yeah.
And if they're not, so what's actually kind of interesting is if you were to use like super, super heavy duty wire and bus bars and overbuild everything, you have more of a chance of there being a problem.
Oh.
So let's say, your resistance is so low. Let's say I'm going to make these numbers up. Let's say one wire is, 0.0001. And then the other wire is 0.0002. So that's literally double the resistance. So one inverter will have double the resistance of the other. So if you don't overbuild the wiring, now you're talking like, 0.01 and a 0.012 or something.
Yeah.
So now instead of having twice the resistance between the two, you're off by like, a tiny percentage. Does that make sense?
Yeah, that's interesting. Wow. Yeah.
So you want to use the proper stuff, but you don't want to overbuild it. And you got to make sure your lengths are as close as you can possibly keep them.
Okay. Well, the last part I missed you. So if you have a really wide fat wire, but they're not equal lengths, you'll mess it up. Is that what you're saying?
Right, because if the resistance is so low that the difference between the two, it's easier to have a bigger mismatch.
Okay. Gotcha.
It's crazy. You have to think about that one for a while to get it.
Yeah.
If I was better at math, I could probably explain it better.
No, I could understand. We could do some measurements when I get there. We'll measure a long wire, like an extension cord, versus a short wire with the same gauge.
I don't know if you've had anything sensitive enough to pick up the difference.
Oh, I see. Yeah.
Here,
Okay.
that can cause a problem.
All right. Well, we'll just. Yeah. Matt's probably got an extension cord, like 100-foot extension cord, and we'll try a little tiny wire. We'll see if we can find the difference. All right. What's next?
So you got your hot 1, your hot 2.
Yeah. Where's the ground?
Yep. They each get a ground.
But that's the 4th wire coming in.
Yep. Sometimes you can just draw a wire coming off of the inverter. So you wouldn't actually draw the ground wire, but it's fine. So you just have a little wire come off with the 3 little lines.
Oh, yeah.
It just means it's the earth ground.
Yeah. Okay. Oh, this is okay. Is this looks like earth or chassis? I don't know. The pitchfork thing?
Yeah, something like that.
One of them's like this, and one of them's like this.
The one on top is the one you would want.
That's okay. This one. Okay, cool. What's next?
All right, so now we're gonna come out. Let's see. So you're gonna have 120 volts out of one of them that you can send to like an outlet. So depending on how much 120 stuff you need, you can use one inverter or both.
Oh. 120 AC.
So there does need to be a breaker in there.
What's the symbol for a breaker?
Um, um,
I know a fuse. I forget the breaker symbol.
yeah,
All right. No
I
sweat.
could. If I saw it, I know it. Trying to
Yeah.
think.
All right, no problem. Okay, so it goes through a breaker. I'll just put a box that says breaker. It's getting a little messy here. I'm tired. Okay, what's next?
So now also one of those 120 legs is going to be both sides of your 220.
Oh, okay.
So again, there's a
Pull
lot of
off
different ways.
here.
A lot of different ways to do this. This is where I think it might be best to consult with the electrician.
Nah, we'll just go for it. So that's got to go to his AC unit, right?
So, hold on. So, actually, this end of it may be a little simpler because you can just run it straight to the existing panel.
Yes.
Because so let's see. So coming in from the street, there should already be some kind of breaker before it gets into the trailer. So that protects the incoming. So you've got your meter at the street, and then there's got to be some kind of breaker.
Yeah, usually your meter boxes have a a main switch.
Street. Okay. From the street.
So now if you take a leg from each of them, and you're just going to go and feed the breaker box like you normally would with any feed coming in, and that'll energize whatever is already energized.
Panel.
And of course you've got your ground and your neutral.
I guess the ground goes in there as well. Sweet. So then he'll have some breakers. Yeah, it's two different phases. They're out of phase. So then that's giving the 220.
So I'm trying to think if you need an additional breaker in there.
Breaker 19.
It might not be bad to have. Well, I think it's as per code. It probably comes down to how far away it is. A few different things, but also that would be like your service disconnect. So I think that might make sense to put a breaker coming out of each inverter, and then you feed the panel.
All right.
I think I'm not 100% sure. Like I said, there's a lot of different ways to make these little connections, different ways to do it.
All right. Super cool. Yeah. Okay, so we'll double check the AC side and no big deal. But for these purposes, really, the AC side is something a lot of people are familiar with. We could probably get that figured out. But as far as the DC side and how to route everything, that was huge. That was instrumental here. Cool.
Yeah, just make sure you make, good solid connections. Make sure you do make a crimp or two and then like do a pull test on it.
Oh yeah.
It's on like a 2.0 cable. You could probably hang from it if you did it right.
Oh wow.
Yeah, I just want to make sure they're solid.
Yeah. Cool. This is good. All right. Well, in the interest of time, I think some people got to go and stuff like that. But we'll let's kill the recording here. But next time we see everybody, we'll be in Illinois, at Taylorville. So this is big, man. This is big. I can't wait. I can't even believe this is happening. So let me just take one thing. I just want to take a look at this other one here. One sec. Oh wait, I don't have the. Oh, here we go. Now this one here is a little different, right? But probably not that different. Here's your batteries. Oh. What's this system for?
It's just a generic system. We're not actually seeing it, are we? Or am I not looking at the red screen?
Oh,
There it is. Okay, I see it now. That was just full screen on you.
what's the difference between this system and the one that we're getting?
Just different. It's hooked up differently, but it's basically the same idea. They've got solar, they've got batteries, they've got the inverters. Scroll down a little to look at the AC stuff. So they're showing the shore power connection in to a breaker. And then they're showing breakers coming out of the inverter as well. I think you don't necessarily need the breakers on the input side because that
Okay.
wire is going to be protected at the meter. But again,
All right.
again, this is code stuff. I mean, it could be different in different states and different countries.
Okay.
It gets down to the nitty gritty.
From my understanding, the main thing is you want to try and fuse for the wire. Is that right?
Yeah. It's always for the wire. Yep. All everything here is all for the wires.
Sometimes, like if you kill a component, that's fine. But the wire, if you kill it, it's in the wall. It actually will heat up, and it could catch fire with something next door to it.
Yeah. If there's a component that needs a fuse, it'll be stated. The manufacturer will tell you exactly what you have to use.
Gotcha.
Actually, did we talk about? Oh yeah, no, we got the fuse on. So the solar panels actually don't really need a fuse. It's more of a service disconnect.
Mm-hmm.
So another thing. Sorry, in the Lynx distributor, that's also a fuse block. So like the solar.
Oh, okay.
So the solar fuse is going to be in there. The fuse for the Lynx is going. I'm sorry, for the inverters are going to be in there. Do they shift?
Yeah, they show it. Oh God, that's too far in. Sorry. Oh yeah, there's a fuse right there. I can see it. That's it. There's fuses in the Lynx. Keep it all the same length.
Yep.
That's what it said. That was the message. Nice. Pretty cool. And then let's see what they do with their positive side. Or sorry, Shore power.
So they've got a switch for shore and a generator, which you guys won't have. At least we haven't talked about it.
Oops, sorry. Yeah.
Would that be a future option to have the shore power circuit included just maybe if you need it later?
For a generator.
That sort of thing, yeah.
Yeah. So there's different ways to integrate a generator, but yep, that could absolutely be added. Yep.
Okay, I see what's going on here. Oh, I see. This is right. This goes out here, and then it goes to there. Okay. And then this one goes to.
You know what? Did I send you the wrong one? Do you see 2 inverters on there?
Okay, hold on. One inverter.
Huh. Maybe I sent you the wrong one because the whole reason behind that drawing was to show the 2 inverters to get the 240. Let me look it up. I may be able to find
Okay.
a better.
All right. Cool. What about these breakers over here? I see.
Not seeing it.
Oh, you don't see this? You guys see the breakers?
Oh, that's follow the wire. What are they going to? So that's going to the MPPT. Is that what it said?
Multi plus.
Oh, because I see why. So if you look at, go back to the positive bus bar, they're calling it.
Uh-huh.
So those 3 devices are getting joined at that positive bus bar.
Oh, yeah.
So the wire changes gauges.
Oh, and then they're fusing for the wire.
Right, because every time you have to, if you drop down to a smaller gauge wire, you've got to put in a smaller fuse.
That's interesting. Yeah, it's a hard concept, but basically you're fusing for the wire, in a way, because you're pulling, if you're pulling more, you
Yeah,
got to put a bigger wire in.
The capacity of the wire has to match the capacity of the fuse. Otherwise, if you have too large a fuse, the wire becomes the fuse.
Yes. What about, is there a chart, ampacity chart that you like using, Matt?
I use the Blue C. So if you type into Google Blue C amp chart.
Okay, I'm going to pull it up. Blue C amp chart.
And they also have a Blue C fuse chart. And this is DC stuff. So NEC stuff is probably going to differ a little bit on the AC side.
This one?
No. They've got a neat little colored one. Should be in there somewhere. Scroll down. Yep, right there.
Oh, I've seen this before. Did you show me this?
Probably. I probably look at it 4 times a day, even though I should have memorized it a long time.
Wow. This is cool. So, oh, I see. So let's say we go 10 feet and we're trying to pull 100 amps. We got to use a 4-gauge wire.
So the other thing that gets people every single time is you need to count both wires. So if you're using, if your device is 5 foot away, you're like, oh, I'm using 5 foot of cable. No, you're not. You're using 5 foot positive and 5 foot negative. So now it's 10 feet, not 5 feet.
Oh, I never thought of that. Whoa,
Yeah.
I never thought of that.
That trips up everybody.
Dude, because yeah, it has to make a loop. Dude, I did not think of that. That's interesting. Okay. That's cool. We use the 2-aught size, and that's because we're doing over 200 amps. And it's
So,
gonna
I
be,
mean, it's overkill. That part of it's definitely overkill.
yeah.
1 gauge would have been fine, but I find it's hard to find 1 gauge wire and lug sometimes. So I just go straight to the 2.
Yeah, 2-aught for the car stuff.
Yep. So what you guys are using is 2 for like the individual stuff. So the batteries are each 2, the inverters are 2, but then where any of those things are combined, it's 2-aught.
Got it. All right, this is cool, man. This is really cool. I think we got a lot out of it. Is there anything else we should add? What, Matt Bloomquist, what do you think, man?
Yeah, I'm. It's all obviously. I can't say it's all new, but I mean, what we're doing is new for me as far as the solar hookup. But a lot of this, I mean, it's all making sense when it comes to how we hook up things in the house or whatnot. And even doing a little bit of the low voltage system, we got to do. I kind of understanding parts and pieces and what the purposes are and stuff. So I'm excited. I think, like I said, as long as we have everything here, I think we'll get it all hooked up fine. And no matter what, ultimately this is going to be a pretty sweet system. And I think it's gonna be a cool thing for me to keep diving into deeper and understanding better. And obviously to pass on to the students.
Nice. Dude, this is awesome. All right, I think we're gonna wrap it up the recording here because this is pretty good. And yeah, Matt Foley, thank you so much.
Yeah, you're welcome.
Yeah, man, and we're it's coming up. We're starting the project on Tuesday, and I will be there Monday, flying in to Springfield. We're gonna make it happen. All right, let's kill the recording right here, and we can hang out for a minute and so. All right, Shop Class Podcast. Next time we see you, Illinois, Taylorville. Boom. All right, see ya.